All right, so yesterday we left off with you talking about car depreciation, and you find the depreciation of a vehicle after 10 years. The vehicle started at $18,000 and it depreciated 20% per year, right? So after doing all the math coming down to it, after 10 years, the car would be worth $1,932.74. Is that what we got? Yep. Okay. Awesome. So we're going to be talking about is the ratio of successive values, meaning we're looking at how did the price change from one year to the other. So the first set of values that we're going to analyze are going to be wherever my pin is. There it is. Oh, I stopped it. All right, so we're going to find our ratio of successive values. A ratio is another word for what?
Like a fraction?
Fraction. We're going to create a fraction. And so we're looking for successive values, which means that one after the other. That's what we're referring to. Okay, so our first value, it's going to be 14,400 divided by 18,000. Did I make a fraction? And ratio is just another way of saying create a fraction. Okay, and we're going to calculate that value. That value is going to give us, we're going to put in the calculator and we will get 0.80. Okay. Your y2 over your y1. Okay. All right, so then the next ratio that we would be comparing is
2 and 3.
2 and 3. No, 1 and 2.
Why'd you cover that?
Because I wrote big. I'm follow my arrows. So we're doing 1 and 2. 1 and 2 is going to give me, what's in my numerator? What's my y2 in this case? 11,520 divided by 14,400. And when you plug it in the calculator, what do you get? You got 0.82?
Are they going to be consistent?
I was about to ask you, based on the fact that our first two are 0.8, is that a coincidence or is that telling us something?
No.
Let's test one more out then, okay? So we're at now, I skip one. You saw nothing. You see nothing.
Crazy.
That line, what? Now we're doing 3 and 2. So that's 9. It's not my Mercedes. Don't worry, guys.
Oh.
All right. So 9,216 divided by 11,520. And what did we find out it is? Not a coincidence. Oh my gosh. The ratio is 0.80. Crazy. Do you see a connection between the 0.80 and the 20%?
Because they both equal a full.
What's the connection there? They equal a whole, right? So the 20% is what it lost in value. That 80% represents what it
is,
what it maintained, right? So if I'm losing 20% every year, cool, I can think about subtracting and losing. But I also can think about what I am maintaining every year. Does that make sense? My car is retaining 80% of its value every year. Make sense? So as we keep going, we would end up finding out that our depreciation, I'm sorry, where is my pin at? There it is. This would be 0.80, 0.80, 0.80, 0.80, 0.80. 8 tenths, 80 hundredths. However you want to look at it, it's still going to be the same for all of them, right? Okay. When we are analyzing this, this was a quick decline. Based on our video, we talked about this represents what type of function? An exponential what? Decay. This is called an exponential decay model. And because of that, this 0.8 is what our decay factor is. Okay. And in our notes, we said that if it's less than 1 but greater than 0, then that's what makes it a decay. And is this value less than 1 but greater than 0? Yes. So we now found our decay factor, which equals our C, which is 80 hundredths. 80 hundredths or 8/10. Okay, so what that means is that instead of us having to do it in 2 steps, we could have did it in 1 step by simply taking the original value, second plus 712, and multiplying by 0.8, what I'm going to maintain. So 18,000 times 0.8. And what do you notice I get right away? 14,400. If I then took that value and multiplied it by 0.8, what do you notice I get? 11,520. Because no longer am I looking for what I'm losing, I'm looking at what I am maintaining. Does that make sense? Okay. This applies to the real world, especially when you're out looking at things that are on sale. If something is on sale for 30%, I can think about how much I'm saving, right? I'm saving 30%. What is 30%? Or I can just think about what I have left to pay. And what I have left to pay would be 70%. Does that make sense? So if I have an item, it's $39.99 and it's on sale for 30%. If I'm trying to do quick math, what would I evaluate there? Would I want to have to find the 30% and then subtract? Or would I just multiply? I would just multiply by that, what I'm going to pay. So if it's 30% off, I'm paying 70%. Okay. I like to do a lot of quick math when I'm in the store. So for example, if it's $39.99, I tell myself, oh, that's $40, right? $40 and I'm in the paying 70%. Well, 10% of $40 is what? $4, right? Can you just move our decimal place over? Well, 4 times 7 is 4 times 7. 28. So guess how much I am going to have to pay? $28. Okay. That's how that works. Make sense? Okay. So 40 times the 0.7 that I got to pay leaves me with paying $28 for whatever item I'm purchasing. Okay. So if you're ever trying to do quick math, trying to see if it's a really good deal, that's how you kind of think about it. Round up to 10, move the decimal, multiply by whatever percent you have to pay. And you can, bam, be magic. Math magic. All right. So now we have our decay, which is our C, our decay factor, which is our C value, right? And we said yesterday that our equation is written in the form of y equals A times C to the X, right? Your A, yesterday, what did we talk about? Your A is your what? Your y-intercept. Your y-intercept is your initial value. Well, do we have our initial value? Yes. Continuation from yesterday. We do have our y-intercept. And so therefore our A equals 18,000, right? So I have my A, I have my C. Can I now write an equation? I can't. So we have y equals 18,000 times 0.8 to the X. And that is my exponential model for the decay of this car. So if I asked you, I am about to ask you, what is the cost of the car? What is the car worth after 22 years? Could you calculate that?
Yes.
So find what is the value of my car after 22 years?
Come back.
Okay.
No.
How would I evaluate that? What does the 22 represent? The 22 represents your X. So if I'm telling you X is 22, can you calculate the value of my car after 22 years? Yes. So I'm going to go to the handy dandy calculator, Sylvie. Open Sylvie. Boop, boop, boop. Look at her, ready to shine bright.
22.
So I have Sylvie, and I'm going to go ahead and put in 18,000, I keep wanting to say 100, times 0.8 carry to the 22nd power. So after 22 years of my good old car, it'll be worth $132.82 if I decide to sell it if it's working still at that point. Your X is, yeah. So your X doesn't, what the X's doesn't change. It's still your number of years. Our output was our value of our car, right? So that makes it our Y. Okay. How do we feel about reading and creating a table and analyzing it for exponentials? It's okay. It's not bad. All right. Awesome sauce.
That's super started.